each section, we are going to solve radical equations and equations with positive rational exponents. All of them are involving with only one variable. A radical equation is an equation that has at least one radical expression containing a variable, while any non-radical expressions are polynomial terms. To solve a radical equation, first we're going to isolate the radical expression on one side of the equation and then raise both sides of the equation to whatever the power is necessary to undo the radical or radicals. This step will convert a radical equation into a polynomial equation. You may gain some extraneous solutions, so we're going to have to check the solution at the end process. Before the end of the process, if any radical expressions remain, simplify the equation if possible, and then repeat steps A and B until the result is a polynomial equation. And then at the step of checking the solution, we're gonna discard extraneous solutions if any, which are the value that cannot possibly be solutions of the equation. Let's take a look at the example. For the first one, we are going to solve the radical equation in a term of the cube root of the expression 2y minus 5 equals 3. This is the cube root, and the equation has a radical form by itself on the left-hand side, so it's good to go for the next step, which means we are going to raise to the appropriate power to undo the radical. We call the cube root. It means the quantity raised to the power 1 over 3. So to undo the cube root, we are going to raise to the power 3 over 1. That means the whole expression raised to the power 3. The cube root of 2y minus 5 raised to the third power equals 3 raised to the third power. The cube root and the cube power, they cancel out, becomes 2y minus 5 equals 27. And then we're going to add 5 both sides. To solve for y, we got 2y equals 32. Divide both sides by 2. Then we get the value y equals 16. And we're going to check the solution by substitute 16 into the original equation. For y equals 16, the left-hand side, the cube root of 2 times 16 minus 5 equals the cube root of 32 minus 5, or the cube root of 27, which turns out to be 3, which is true. So the answer is 16. The next equation, we have the radical of 50 plus 7x minus x equals 8. The radical form is subtracted by x, so we are going to keep the radical by itself. So we're going to add x both sides. And then the left-hand side, just leave the radical form by itself. Equals the right-hand side, which is x plus 8. So the square root means the quantity raised to the power 1/2. To undo the square root, we are going to raise to the power 2. So that will make the radical form disappear. So the next step, we are going to raise both sides to the second power. The whole quantity on the left, the whole quantity on the right, raised to the second power. Next, The radical and the power 2 cancel out, becomes 50 plus 7x on the left hand side, and the right hand side is the product of x plus 8 and x plus 8, and use the Fourier technique, simplify or expand them to get x squared plus 16 times x plus 64. At this point, we have the polynomial equation. The radical is gone. Now we're gonna solve this polynomial equation by moving all terms to one side, and then the other side is 0. Since x squared, which is the highest order, on the right hand side, so we're gonna move every term to the right by subtracting 50 and 7x both sides of the equation. Now we get 0 equals x squared plus 9x plus, this is 50, plus 14. We got trinomial or the polynomial with the 3 terms, and the leading power is 2. The leading coefficient is 1. We're going to solve this equation by factoring. For the number 14, will be the product of 2 numbers, that the sum equals 9. The 2 numbers, the product is positive and the sum is positive. That means both of them are positive. So we think about 7 and 2. So 7 plus 2 is 9. 7 times 2 is 14. So check. Therefore, the right hand side is factored to be x plus 7 times x plus 2. And then we get x equals negative 7 as one solution, x equals negative 2 as another solution. And now we're going to check the solution. Let's clean up a little bit here. Let's check the solution for x equals negative 7. The original on the left hand side, square root 50 plus 7 times negative 7, and then subtracted by the x value, which is negative 7. It becomes square root of 50 minus 49 plus 7, or square root of the 1 plus 7, which is 1 plus 7 equals 8. Check. So we keep this solution. And do the same for the second one, which is x equals negative 2. Square root of 50 plus 7 times negative 2, subtracted by x, which is negative 2. Simplify the radicand, we get 50 minus 14 plus 2, or square root of 36 plus 2. Square root of 36 is 6, and then added by 2, the result is 8. Check. So we keep both solutions. Next example, we have the cube root of the expression 6y squared plus 27y equals the cube root of 2y to the second plus 40. We have 2 radical forms, and then each side has only one single or the single radical. We are going to raise both sides to the 3rd power because the cube root of the quantity is the same as raising to the power 1 over 3. To undo the cube root or to undo the 1 over 3, so we're going to multiply by 3. That means we're going to raise all to the power 3. Copy the original expressions. And raise to the 3rd power. Do the same for the right hand side expression. The cube root is gone. Now we have 6y to the second plus 27y equals 2y to the second plus 40. We got a polynomial equation at this step. Then we're going to solve for y. We have the y to the second power on both sides. So we're going to collect all the terms to one side. We subtract 2y squared, both sides of the equation. And then we get 4y squared plus 27y minus 40 equals 0. We got trinomial or the polynomial with 3 terms, but the leading coefficient is not 1. Since the coefficient is not 1, this considered the A, and this is the B, and this is the C. So we're going to use the grouping technique by multiplying A and C first. So A multiplied by C, which is 4 times negative 40 or negative 160. And then we're going to break this number into 2 numbers, multiply each other, but add together to get the value B, which is 27. Think about the numbers. If the product is negative, that means one quantity is positive, the other quantity is negative to get the product negative. And the sum is 27. That means the larger quantity is positive inside. So think about the 2 numbers that opposite inside, but the product is negative 160. Let's make a list of the pair from the lowest number, like 2 and 80, 4 and 40, then 20 and 8, and 15 and 10, 32 and 5. Looks like 32 and 5 is the right pair. So we have positive 32 minus 5. So the sum is 27. Next, we're gonna use the grouping technique by breaking this into 4 terms and then regroup them. We got 4y squared plus 32y minus 5y minus 40 equals 0. This step we are going to use the grouping technique. So the first 2 and the last 2. 4y squared plus 32y plus the other group, which is negative 5y minus 40 equals 0. And then factor the GCF, or the greatest common factor. The first group, the greatest common factor of the number would be 4. Of the y would be the lowest power, which is y to the first power. The remaining factor would be y plus 8. The second group, the common factor would be negative 5, and the remaining factor would be y plus 8 equals 0. Now we have the common group, or the common quantity. We get y plus 8 as a common factor multiplied by 4y minus 5 equals 0. Use the 0 factor property. We get the 2 solutions. The first one, y equals negative 8. The second one, y equals 5 over 4. So from 2 answers, we are going to check the solutions. So check. For the first one, the original equation is Let's see, the original equation is the cube root of 6y to the second plus 27y equals the cube root of 2y squared plus 40. So for the first one, y equals negative 8. The left hand side, the cube root of 6 times negative 8 squared plus 27 times negative 8. Is that the same as the cube root of 2 times negative 8 squared plus 40? So let's work on the numbers. So 6 times negative 8 squared. Negative 8 squared is 64. 64 times 6, that is 384. And then subtracted by 216, which is the product of 27 and 8, to get the cube root of 168. And then on the right hand side, the cube root of 2 times 64, which is 128 plus 40. That turns out to be the same number as the cube root of 168. So the first solution is good. So we keep y equals negative 8. And then another one where y equals 5 over 4, we would do the same. To the left hand side, the cube root of 6 times 5 over 4 to the second plus 27 times 5 over 4. Is that the same value as the right hand side, which is the cube root of 2 times 5 over 4 squared plus 40? And then work on the number, and it turns out to be the same value, where the left hand side is the cube root of 345 divided by 8, same as the right, which is the cube root of 345 divided by 8. So we keep both solutions. Another example of the radical equation. This time we have the radical form on one side, but two terms. So we are going to separate them to keep one radical on each side. So square root of x plus 1 equals 1 minus square root of x plus 2. And to undo the square root, we're going to do the power to both sides of the equation. Copy the original and then raise to the second power. The left hand side, the radical is gone, becomes x plus 1, where the right hand side, we have to do the perfect squared. That means this is the same as the quantity 1 minus square root of x plus 2 times the quantity 1 minus square root of x plus 2, and then expand this out to be 1 minus 2 times square root of x plus 2, and then added by the quantity x plus 2 equals the left hand side expression, or x plus 1. And then simplify as much as we can. We have x plus 1 equals 1 minus 2 times square root of x plus 2 plus x plus 2. We still have one radical to take care of, so leave that radical by itself and then move the other term to the other side. Since the radical has the negative coefficient, so let's rearrange term a little bit by adding the radical both sides and move all terms to the other side. And at the same time, we can see x and x here can be reduced. 1 and 1 can be reduced. So we could get 2 times square root of x plus 2 equals the value 2. And then divide both sides by 2. We have the square root of x plus 2. This one cancel. This one cancel. We have square root of x plus 2 equals 1. At this point, we have the equation with one or just a single radical. To undo the radical or the square root, we're going to raise to the second power. And then the radical on the left-hand side will be gone. Leave us x plus 2 equals 1. Therefore, x equals negative 1. We got this solution. And next, we're going to check whether we should keep this solution or not. For x equals negative 1, the original expression would be square root of x plus 1, which is negative 1 plus 1, plus square root of negative 1 plus 2. Put question mark over here. Let's see if it comes out to be 1. So square root of negative 1 plus 1, that is 0. Square root of negative 1 plus 2, that is square root of the 1. Yes, it turns out to be the same as the right-hand side value, or we can say this is a true statement. So then we keep this answer.